This is rational solving. We'll look at equalities and try to get into some inequalities, but the main thing we'll do is look at word problems. And a great place to start is go online. You got to check out the 2014 hot dog eating contest, 2014, and there's a guy named Chestnut and Ernie battling for the win. And Chestnut can eat 70 hot dogs in 10 minutes. Both Chestnut and Ernie can eat 100 in 8 minutes. How long will it take Ernie to eat 30? Now this is going to use a real basic rational function, but what's really key is you'll see these, I've seen these on ACT test questions, and they've always baffled me a little bit. But once you kind of see how to set these up, these are super, super easy. But check out the video first, and just go online, of course online. Look at the YouTube and check out the hot dog eating contest. I can't remember who I think it's Nathan's Hot Dogs is the company that sponsors it. All right, so what you're trying to do here is you're trying to simplify this kind of problem. And the way you simplify it is you do your best to think of the basic idea. And the basic idea is that we're talking about rates. People eating hot dogs, amount per time. Most rates are going to be that, amount per time. So think of this guy named Chestnut. His rate is going to be 70 hot dogs in 10 minutes. Okay? Both Chestnut and Ernie, so the rate of both is going to be 100 hot dogs per 8 minutes. Okay? Now, if you think about it, this is the formula, but the big idea is the rate of Chestnut, the rate of Ernie, and the rate of both should be related. So think of it this way. The rate in which Chestnut eats hot dogs, the rate in which Ernie eats hot dogs, if you added those up, you should get the rate of both. So all of these problems are either going to be rate plus rate equals both, or time plus time equals both, or distance plus distance equals both. Either way, you're going to have a simple formula of rate is amount over time, and you're either going to add rates, add times, or add amounts. So this one, think about it. Those two rates have to add up to both. So for Chestnut, it's 70 over 10. Okay? For Ernie, we want to see how long it would take him to eat 30 hot dogs. We don't know the time, but we know he's going to eat 30 in an X amount of time. And it took both of them, they could both eat 100 in 8 minutes. But that rate of both of them is going to be the combined of the two individual. So the rate of Chestnut is 70 and 10, which is 7. Rate of Ernie, which is 30 over X. The rate of both is going to be 25 over 2, I think. Does that sound about right? When you divide both by 4. So then what I would do is I would multiply everything by 2x, both sides. And these two will cancel. These two will cancel. You'll get 14 plus 30. Well, is this 14x? Yeah, 14x plus 30 is equal to 25x. So 30 is equal to 25 minus 14x, which is 11x. And so x is going to be 30 over 11, which is like 2.7 or something like that. So it would take Ernie about a little under 3 minutes to eat 30, which sounds about right. But what you're probably wondering about is what was that move that I did here? Let me go through that one more time. What I did algebraically is what we call clearing the fractions. So 70 over 10 plus 30 over x equals 100 over 8. So what I did is I multiplied by 2x, 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 2x. And the reason I multiplied by, oh, wait a minute here. Oh, I simplified them first. This was 7. And then this was fine. And this was 25 over 2. But what you can see is that when I do the 14x plus 60, I must have missed that, didn't I? I think I missed that, is equal to 25x. Cancel out. And then you're going to get 60 equal to 11x. Thought that seemed a little low. 60 over 11 equal to x minutes. So that'll be about 5.5, something like that. So there you go, hot dog eating contest. Let's look at another one. Carl decides to explore the Meander River, location of several Sasquatch sightings. From camp, he canoes downstream 5 miles. Okay? Check out the nest. Finding nothing, he turns around, this time traveling upstream. He returns to camp in 3 hours. So the time going downstream plus the time going upstream, because he goes over and back, is going to be 3 hours. So again, break it into time adding or rates adding or distance adding. We're going to do that. If Carl canoes at a rate of 6 miles per hour, what is the speed of the river? So think of the river going in this direction. Okay? So if you're looking at rate, speed is distance over time. So time is distance over speed. So the time going downstream is going to be 5 miles over the speed. Well, he can go 6 miles per hour, but he's going to be going with or against the speed of the current if he's going downstream. Well, he's going to be going faster, so we can add the speed of the current. The time upstream will be 5 miles over 6 miles per hour, but this time he's going to be fighting the current. So what do you do with that? You subtract it, equal to 3. So the final formula is just going to be 5 over 6 plus v plus 5 over 6 minus v is equal to 3. So you're going to need to do a lot of multiplying here. You're going to probably want to clear this fraction. You're probably going to want to multiply by 6 plus v, 6 minus v, 6 plus v, 6 minus v, and then 6 plus v, 6 minus v. So these will cancel out, and you'll get 5 times 6 minus v. And here you're going to get 5 times 6 plus v. That's going to be 3 times 36 minus v squared. So 30 minus 5v plus 30 plus 5v. Uh-oh, those are going to cancel. But of course, you're going to get, let's see here, 108 minus 3v squared. So these are going to cancel out. And you're going to get 60 equals 108 minus 3v squared. 3v squared equals 108 minus 60. And if all is well, I'm going to get 32, I think. No. No. No, 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 no. 48. So v squared equals 16. And of course, there's two speeds for the current, either -4 or +4. The one that makes no sense with reality is the negative. So my speed of the current is going to be 4 meters per second. I think they use meters per second. Right? So the idea again is think of time adding to get a total time. With this last one, speed adding together, rate adding together to get total rate. And then substitute and solve. Let's try a quick one here. Working alone, Taylor can weed the garden in 4 hours. If Carl helps, they can weed the garden in 3 hours. How long would it take for Carl to weed the garden? So it looks like the rate for Taylor plus the rate for Carl will be what for the rate of both? Well, they should equal, shouldn't they? So remember, rate is amount per time. So for Taylor, the rate is 1 job divided by, takes her 4 hours. For Carl, it's 1 job, and it takes him 3 hours. Oh, wait a minute. No, we don't know what his hours are. But we do know what it takes for 1 job for both of them to do, and that's 3 hours. So let's check this out one more time. Taylor can weed the garden in 4 hours, 1 job in 4. If Carl helps, they both 1 job in 3 hours. We want to find out what Carl's rate is. So it's 1 over 3 plus 1 over x equals 1 over 3, 1 over 4 here. Okay, so 1 over 4 plus 1 over x equals 1 over 3. If you multiply these all together, you're going to get 12x. So I'm going to multiply everything 4 times 3 times x. 4 times 3 times x. 4 times 3 times x. And notice that the 4's will cancel, the x's will cancel, and the 3's will cancel, leaving 3x plus 12 equal 4x. Subtracting 3x, and you'll get x is equal to 12. So Carl, if he only takes an hour off of that, he's pretty slow. He can do the job in 12 hours. And then always take a look at problems that have unknown variables. We have the square box problem. And what they're doing is they're saying that the height is x, or no, it says, let's see, a box with a square base. So this is x and this is x. It's a volume of 1,000 cubic centimeters. Let x denote the width in centimeters. So we don't know what the height is, but we do know that the volume is height times width times height, or hx squared. And they're saying for this problem, the volume is 1,000. Okay? So if 1,000 equals hx squared, I think h is 1,000 over x squared, which we're going to be able to use. Express the height as a function of x. Ta-da! Done it. All set. Solve h of x greater than x. Well, if h of x is 1,000 over x squared, and it's greater than or equal to x, we can solve for x. Since x is greater than 0, then we can multiply this x to the other side and just get 1,000 greater than or equal to x cubed. Cubed rid of both sides, x is going to be greater than or equal to 10 will be my domain. X can't be smaller than that, because if it's smaller than that, smaller than 10, whoops, did I do that wrong? Wondering if I did that wrong. Height is greater, oh, okay. Yeah, so if x is smaller than 10, you can't have a height greater than the width. So in order to have the height greater than the width, in order to have height greater than the width, you're going to have x less than or equal to 10. Find and interpret the behavior of h of x as x goes to 0 from the right, because it's got to be real, and x going to infinity. So I love this question a lot. With this one, you have h of x is equal to 1,000 over x squared. So let's take a look at the limit as x goes to 0 on the plus side, just a little bit over. So it's essentially 0. So 1,000 over 0, that is infinity, right? Positive infinity. So this is going to be, if your width gets really, really tiny, close to 0, your height would have to be really, really tall to get that. And then the other one, what if x was approaching infinity and you have 1,000 over infinity squared? Well, that's just going to be 1,000 over infinity is essentially 0. So in this case, if your width is really, really big, the height is small. If the height is really, really small, your width is really, really big. So that's what these two are saying. And then express the surface area of the box as a function of x and state the applied domain. So surface area is going to be the base, which is x times x, plus 1, 2, 3, 4, sides, which are h times x. Express the surface area S of the box as a function of x and state the applied domain. Now I'm just going to say that we're thinking this in terms of amount of metal or cardboard or whatever. We're not looking at the front and the inside and the outside of the box. I'm just looking at the material for the base, material for the 4 sides. So that surface area is going to be x squared plus 4. Now h is 1,000 over x squared, and don't forget to multiply by x. So that's just 4,000 over x. Okay? So you can see why you can't have x equal to 0. So the domain for this one has to be x greater than 0. Can't be equal to 0 or it'll be undefined. Use a calculator to approximate the dimensions of the box, which will minimize the surface area. So put this into your calculator, and when you look at surface area, it's going to go like this. Okay. I want to know what this x is. Very cool. So that is minimizing, maximizing, and using your knowledge to figure out word problems. Here's a couple of practice graphs. And, I just wanted to mention these inequalities. All that you're asking to do here for all of these is you first find your vertical asymptote, which in this case is x equal -2. Look for your zeros, x-intercepts. Set the numerator equals 0. There are none. So the only one that's a vertical asymptote is -2. And then when you do your test, just see where this is greater than or equal to 0. Well, we know where it's equal to 0. Well, actually, we don't because it can't ever get there. But we know where the vertical asymptote is. If this is positive, okay, 1 over -3 plus 2, for example, 1 over -1, is that greater than, is -1 greater than 0? No. So that's not true. Let's try the other one here. Let's try something like 0. So 1 over 0 plus 2, is that greater than 0? Yes. So since we have this set up, this number line set up, all you have to do is say that the area, or the solution is x greater than -2. This part here, the yellow. It's open, and then it's all these. And you'll do that for each of these. Notice 8 has 3 and a -2 you're going to have for zeros. This one, unfortunately, you're going to have a 1, a -1, and a 0. Do the number line thing, see where it's true. Easy. Your answer will be an inequality. You might have unions involved, and that's how you solve for inequalities. Try these problems. I helped set up number 1. 21, 22 is a Monty Python problem. 24 and 25 are great practice problems for word problems.